Nobody, okay.
Which of the following, FF is just following, okay? Which of the following statements, right, or there's an expression here, would be valid, okay? So remember, you're checking for, are the two angles that are on either side of the equal sign, do they add up to 180? That's like the first thing you check, okay? And then you want to say, you want to make sure that both sides are actually equal to each other. So when it's 7 and 173, right, I check this. I'm like, that adds up to 180. Okay, I can continue. If it's cosine, what do we need for cosine for these sides to be equal? Do you remember if you watched the video? Is this a true statement, that cosine of 7 is equal to cosine of its supplement? The answer is no, okay? So grab your calculator so you can actually find out just by doing this. If all else fails, you go cosine of 7, that's 0.99254, and that keeps going. And then cosine of 173, what do you expect that to be? What sign will cosine of 173 have? It'll be negative, right? It's negative 0.9925 and something. So are these the same? No, they're not. Okay? One has a negative, so it's not the same. You can cross off the equal sign and you just say false. Okay? If one of these statements, if you look up here, if one of these had a negative in front of it, it would have been the same. Okay? So for cosine and tan, you cannot have the same sign, okay, if they have to have opposite sign. So what about this one? We check 67 and 113, they do add up to 180. Okay, so now we can continue our search. This is tangent, right? And one of them has a negative in front of it. So this is actually a true statement, I can tell you that already. But if you don't remember, you go minus, find out what tan of 67 is. That's 2.355 and something. And we're saying that that's equal to tan of 113. Hey, it's also negative. Okay, so these statements are actually true. That's a true statement, okay? I won't do a whole lot of these over the course of this unit and even on the exam, but every once in a while it may come up. So you just have to know that. What about sine of 56 and sine of 34? The shortcut would be, or the shortcut is checking, right? Do they add up to 180? And the answer is no. This is not equal to 180. So immediately you just go false. Like it's not even a contention. You need to have supplementary angles there. This one, 91 and 89, do they add up to 180? Yes. Do they have opposite signs? The expression, yes. So true. Okay. Can I go up here again? I check for 180 first, right? For 180, and then I check for signs. Right? They have to have opposite signs if it's tangent and tangent and cosine. So that keeps going. So 73, 107, that's 180. Yes, they have opposite signs, so this is true as well. Okay, cosine and cosine, they are supplementary. They have opposite signs. That would also be a true statement. And if you don't know, just type it into your calculator and check if both sides are equal. Okay, and that'll tell you that for sure. Next part here: calculate the following ratios, then predict the ratio of the supplement. Okay, so figure out what sine of 80 is. Did I do this already? I think I posted this maybe. Sine of 80 is 0.9848. Let's just round to 4 decimals there. You can predict that sine of the supplement, which is 120, we can predict that it's going to be exactly the same. That is actually a problem, that sine law doesn't know the difference between taking the sine of 80 and taking the sine of the supplement of 80. It doesn't know the difference. It just can't, right? That is the main problem why sine law we'll have to do some investigating. Cosine of 30. So if I asked you, cosine of 30 is 0.8660, okay? What would you know without using your calculator? The supplement is 150, right? What would this be over here? If it's obtuse, you can bet that it's going to be the same value, except for it being obtuse tells you that it's going to be negative. Okay? So that's what I want you to know here. Tan of 140, tan of 140, tangent. We haven't used it, and we're not going to be using it, but it still is important to know. So tan of 140 is negative 0.8391. That means that tan of the supplement, which is 40 degrees, will have the same numerical value, but it will be positive. Okay? So if it's sine, it's the same. No difference in sine. If it's cosine and tan, the acute angle will have a positive, the obtuse angle will have a negative sign. That's what you need to remember. So sine of 143, let's do that one real quick. Sine of 143, that's 0.66018. Okay? And therefore, sine of the supplement of that would be 37, right? If you took that away from 180, we know it's going to be exactly the same. So sine is doing this every single time, okay? So let's say you're referring to an angle of 143. We know it kind of looks like this, right? This is 143. Okay? Sine will by default actually always assume that you mean this one here, the acute angle, this one. Instead of the 143, it will assume that it's this one here, 37. It will always default to the acute angle. That's a problem with sine, because sometimes we do have an obtuse angle. It's just it won't know. So that's where you come in. Okay. All right. Let's go into what this means for us. This problem here, sine not knowing whether it's obtuse or acute, it poses a problem for us. So here we go. I'm going to ask you to go straight. We're going to skip a bunch of pages. We're going to go to 103. This is something that you want to add to your study sheet. This you're going to summarize it, and I might give you a cheat, like a smaller version of this on the whiteboard. Not today, but in the days to come, right? So applying the ambiguous case of the sine law, and this is particularly to SSA scenarios, okay? And we're going to have to determine the number of solutions, so that's new, okay? What do you mean number of solutions? There could be multiple solutions here in this case, okay? So when given a non-right triangle, an oblique triangle, right, and we determine that it's an SSA, I don't know if you remember that, but sine law is the only one that can deal with an SSA scenario. Okay? We need to take extra precautions, especially if there is no diagram provided. That's important here. Okay? So SSA sine law, if there's no diagram, you're going to have to take extra precautions. So the first one is SSA when the given angle is acute. So this only angle that you're given, you notice that it's acute, all of this happens. This whole page is a bit of a flow chart. So here we go. You want to force your diagram to look like this. So you always want it like this, okay? Where this is one of the sides, this is one of the sides, and this is the only angle that you're given. Okay, so just follow me right now. You want to draw it like this, and then you want to ask yourself, is the string, rod and string, in case I just made this up, right? Rod and string. I like fishing, right? So I'm thinking of this is my fishing pole, my rod, and this is my line, my string. And so you're fishing, right? Instead of using letters, I often just use rod, string. It's easier to work with, okay? So the first thing that you want to ask yourself is the string, okay, is that number, there's going to be a number here, okay? Is that greater than or equal to the rod? That's what you want to ask yourself first and foremost. If the answer is yes, if you can interpret this and you go, yes, it is true, then guess what? One possible solution okay? One possible triangle. Same thing. Sometimes you use solution, sometimes you say triangle. Okay? So they mean the same thing. I will add a note here because sometimes students down the road, they always find the height. I will put in brackets here. No need for height. I will highlight that part. No need for height. So you're done. It's like nothing ever happened before. Okay? If your answer is no, like if you go arrow down to here, then you must take the next step, which is finding the height of the triangle. Okay? Do you remember how to find the height of the triangle? The shortcut? I hope you have it on your study sheet. But the height, in this case, come on, don't break everything here. It would be rod times sine of this angle here. Okay? So we will go rod times sine of, in this case, it's angle x. Okay? That's how you find the height. And so this, I will actually give this a red pen here over. So then you try to find the height. You actually try to determine this. And this is how you get it. That shouldn't surprise you. Okay. So just write this down. And now it gets interesting. Okay. So let's add this here. I need to add something here. If you're saying no to this, look up here on the screen. If you're saying no to this, a string is greater than or equal to rod is no. That is actually saying this, right? String is shorter than rod. That's what you're saying effectively. Okay, if you're saying no to that, then you're actually saying this, that you're noticing that, hey, the string is shorter than the rod. Okay, and therefore you must find the height. And then you have three things that you can conclude from that. So here it is. If string is the main character in this whole thing. If the string is less than the height, that's one scenario. The string could be exactly equal to the height, or the string could be greater than the height. I will give string a color because I think it's important to do that. So let's go up to our diagram real quick and use a highlighter of your choice. And I'll just say the string is here, right? So that's like your main character. So first we compare the string to the rod first and foremost. You've got two choices. It's either a yes answer or it's a no answer. Okay, if the answer is no, we need to find the height of the triangle. Once we have the height, we take the string again, and the string gets compared to the height in every scenario. Okay? You're looking at string versus height. So first it's string versus rod, then it's string versus height that we talk about. And I'll give you a cool interactive example later on. I just have to get my iPad out for this. So here's what's, if the string were to be shorter than the height, you have no solution, okay? So then it goes like this. It would imagine what we just had up there. You have your string. This is the height here. This is the string. If this string is shorter than the height, guys, right? If this is actually shorter than the height, do you have a triangle? I would argue no. This is just gonna dangle like this. Like if you let go of the string from here, it's just gonna dangle like that. It will never touch the bottom here, which is a requirement to actually make your triangle. So no triangle, okay? No solution. No triangle. So this is going to be an awesome whiteboard activity to determine this, to break this down. Go ahead. Okay, and I'd like you to have a justification why you came to this conclusion. You said first and foremost that the string is shorter than the rod, right? And another conclusion we faced is string is shorter than the height. So that's why we said no solution possible. And I know it's a little overwhelming right now, but trust me, you will do example after example, and then you'll come up with the right way of doing this. If the string is exactly equal to the height, you've got this scenario. Let me just sketch this here. Your height is going from the top straight down, correct? And this is then the string as well on the side here. What kind of triangle do you have there? If this string is exactly equal to the height, it will touch it right down here. So you actually have one solution, one triangle, and in particular, a right triangle. How did you determine this? Well, remember, if you make it all the way down to this flowchart, you have said right at the beginning that the string is shorter than the rod. But now our conclusion is that the string is exactly equal to our height, so that's how this is different. Make sure you write this down because you're going to need it. Okay. Your third option is that the string is longer than the height. And this is the interesting case. This is the most interesting case that we're going to study, right? That we're going to cover. You got to imagine this is your rod. This is the ground, which we don't know how long it is, right? And this is your string. So the string is actually, it makes contact here. This is your string. And your height is down here, okay? You got to imagine the string can make contact here, or you can take it, it's almost like a weird thing where we swing it, and it would also make contact here. This is also the string. So you could have a triangle that looks like this, or you can have this big triangle outside here, okay, on the outside. So I will actually add that to your solution number 1 is this. Solution number 2 is this. Okay? So you have or. You got this one or the big one here on the outside. So 2 solutions / 2 triangles. And again, you went string is shorter than the rod, but string is greater than the height. That's like the short That's the short justification as to why you concluded this. Fun stuff, eh? Just hang in there. Just hang in there. I'll distill it for you. Okay. Once you've copied this down, I want to say something here. You will only ever end up in one of the roots, okay? You will either end up in this camp, you will either end up in this camp, or the one that's the easiest one is this camp right here. This, if you say that string is greater than or equal to rod, if your answer is yes, you can forget about all of the stuff that came thereafter. And just so you know, I always made sure that all the SSA scenarios had the string being longer than or equal to the rod. Every single one. If you go back in your worksheets, every single time the string was longer than the rod. So you never had to worry about this. You never encountered this mess right here, okay, until now. Okay, so now everything changes. So this is if it's acute, if it's an acute triangle, right? Remember, we found out that this was an SSA and that the angle that we were given is acute. So then all of this applies. It is a lot easier if it's obtuse. Okay? So go to page 104. Go to page 104. There's the string again. I'm going to give it the same color as I did before. What does it say here? So first I would say that this is the obtuse case. There's no need to find the height. Make sure you understand that. That's not necessary with obtuse. Obtuse is much easier than that. Okay? So the only angle that you're given there is obtuse. And you have two options. Again, rod, this is when you caught the fish, you're pulling back, right? Pulling the rod back. If this string is greater than the rod, you've got one solution. Done. One triangle. If you notice that the string is less than or equal to the rod, even if it's equal to the rod, you've got no solution. That's how easy this one is. No, not much to it. Okay. Obtuse. So we've got two camps. We've got acute, obtuse. Under the acute, it gets messy. Under the obtuse, it's a lot easier. You just have to compare the string and the rod. I will actually highlight the string every time. Because in all of these, the string is your main character kind of the play. Okay? String is always about the string compared to the rod. Okay. All right, let's try a few so you can wrap your head around it. I should have made it in such a way that you can rip this out and keep it for a little bit, but unfortunately it didn't work out. So let's go to 105 here. Page 105. Okay, so you got to bear with me here. You got to try your best. I'm not going to do any of the finding the height, any of that right now. I give you everything. This is your height. This is your height. Rod, string, correct? So what's the first thing we look at? We look at string versus rod, correct? And look at the numbers. What do we observe? The string is shorter, less, right? Shorter than the rod. Okay, so I'm going to flip back and I'm just going to ask you, what happens when the string is shorter than the rod? We find the height, which you already know, and then we compare the string to the height, and it could be one of these three camps here. Okay, so let's see what happens. If we compare the string to the height, what do we notice here? Just look at the numbers. The string is shorter than the height. So what camp are you in? You are in this one right here. String is shorter than rod, we established that, and the string is shorter than the height. So you basically have a triangle where it's just dangling like that. You cannot close it, okay? So this would be, therefore, no solution. You don't have a triangle, folks. It's not possible. Okay. I'm just going to add, I'm trying to help you here. Can I go to here, to this scenario, and I'm just going to say string is greater than or equal to rod. That's the only justification that you need to say, hey, this is just for one triangle scenario. We're done. Like, we don't need to keep going with the height, okay? So maybe all of these boxes here, this one up here where my pencil is right now, and these ones here, that's all you maybe need, right? That's all you really need to know. So let's keep going here. First, we're going to go string compared to rod. This is our rod. This is our string. Don't mix that up. Okay. What do we notice about the numbers? The string is shorter than the rod, correct? So we're going to go like this. That means that we have to compare the string and the height. What about the string and the height? String is less than the height. Do we have a solution? Nope, no solution. The same as before. This cannot be solved, and I'll show you that later. You cannot solve this one. You will get a, okay, yeah. You will get a math error on your calculator if you try to solve one, okay? Let's keep going here. Just hang in there with me, okay? This is our rod, this is our string, this is our height. Don't worry about the height right off the get-go. Let's just worry about the string and the rod. Just put down string and rod. We notice that the string is shorter than the rod, so do this. Then we compare string and height. What do we notice here? 5 and 5, that means that the string and the height are exactly the same. Okay? So that means that what scenario are we under? Go look at your cheat on 103, sorry. A right triangle, correct? You have a right triangle? Yes. You can say one triangle, one solution. Watch how I write solution sometimes. That's just to shorten it. This is a right triangle, actually, specifically. We know that's a right triangle. And I don't know if you're thinking, Mr. Dirksen, why do you draw them so weird? Like, why don't you just make it closed here? Because technically at the beginning we don't know.
Mr. Alford to the guidance office. Mr. Alford to the guidance office.
Okay, can I ask you to do these two here on your own? Go through what I just did. See if you can come up with that. And E, F as well. E and F as well. If you need to consult with your neighbor, please do so. Because you might learn. All right, so this one. You should make sure rod and string is right, the height is there. Just so you know, down the road, the height you'll have to calculate. But right now, everything is given. So I'm going to go string and rod first and foremost. What do I notice about the rod? Oh, sorry, the string compared to the rod. It's greater, right? You could say it's greater than or equal to it. It's fine, because that's the one question I ask you to ask, right? And so that's it. One triangle. No need to even worry about the height. If you did, it's not the end of the world. It's not wrong. But there's no need to continue further. Okay? Next one here. Rod, string, height. So you compare your string and your rod. Oh, the string is shorter. Okay, I have to compare the string and the height. The string is actually greater than the height. Therefore, I have two triangles here. Okay? So this is how you would justify. That's all I would ask you to do. Okay? The string here is 32 compared to 24, right? You're like, Mr. Dirksen, look, it looks shorter. I can tell. This is just a troubleshooting tool. Okay, this is not, we're not drawing this to scale. So you want to look, you want it to look like this every time and then make your conclusions here. Okay? One more. These are all, can I just do this? These are all acute. I don't know if you, like all of these were under the acute category. Okay? Acute. How do you know? Just by the diagram. That's it. Okay? And now we're dealing with obtuse. Right? So these ones are all obtuse here. So all you need to do is, this is rod, this is string. We don't even worry about the height. You can actually cross it out. I put it down there, but we don't need the height, just the rod and the string. Okay? So over here, you're going to compare the string and the rod, and you can tell that the string is greater than the rod, therefore one triangle. That's it. Over here, the string is shorter than the rod, therefore no solution. Okay? That's how it goes. I know, it's painful, but we have to rip the Band-Aid off and just do it, okay? All right, let's go to 106. I'm going to step it up a notch, and then I will actually ask you to do some group work on this one. You need to wake up a little bit, right? Okay, folks? In each case, determine if it's SSA. I'm going to say this, and I hope you remember. If it's not SSA, you're listening, right? You do not worry about all this mumbo jumbo here, right? All this stuff that I'm talking today is like absolutely does not apply to anything but SSA. And I will help you identify an SSA case, okay? If so, determine how many solutions are possible and justify. That's important here, to justify, okay? So what do we have here? Triangle ABC has angle A, side B. If you have the angle, all right, you know by letter A, and the side across from it, which is lowercase a, you know, and another side. So you've got two sides, and these are particularly across each other. You know that this is SSA. Guaranteed. It's not the cosine law where it's SAS, right, where you have the two sides and then the angle in between. So that tells us that this is an SSA case. So, watch carefully. You must do one of these. Just go ahead and do that. Just go ahead and do that. Like, that's what it will look like every time for me. You force the angle that you're given to be here. Okay? Which means that the side across from it, which is this one, will go over here. That's your pair, and then the other side that you're given, guess where it's going to go? Over here. That's my rod, that's my string. If you go RS, if you label your triangle RS, then you're fine with me. You can always use RS if you'd like. You just got to make sure you label it on this guy. Because it could be triangle XYZ, it could be, you name it. So technically this is angle A, but I'm just going to leave it like that. Okay? All right, why do you do this, Mr. Dirksen? Because we actually don't know if we have a triangle or 2 or 0. Like, we don't know that. So we're going to say this. String compared to rod. What do we observe? The number, just by the number. String is bigger than the rod, correct? Therefore, one triangle. That's it. You don't have to worry about the height. If you notice that, you're done. You don't have to worry about that. It does not become an issue. No need for height. I'll just write no need for height. We're done. Next. Triangle XYZ. There's angle Y. There's side Y. Oh, so what do we know? possibly an SSA because this is another side. Okay, so two sides and an angle, and if you've got the pairs up like that, that's SSA. Guaranteed. What kind of angle is this? Obtuse, do you notice that? Just a few exclamation marks so you don't miss it. Anyways. There you have it. So what does your rod and string look like? It will look like this. This is your rod. This is kind of like the ground here. And so this is what it will look like. You put the 127 in here. And guess what? The side across the angle, in this case, is 25 centimeters. And the other side is 30. This is rod, this is string. The only thing you need to worry about when it's an obtuse is comparing the rod and the string. That's it. What do we notice here? That the string is shorter than the rod. It's just not going to close. Okay? Therefore, no triangles, no solution. This triangle cannot even exist the way it is right now. Another one. Let's see this one here. You've got triangle DEF, you've got a side here, another side here, and you've got an angle. So two sides and an angle, correct? We don't know if it's SAS or if it's SSA. But you look at F and F here. Okay? That tells you that this is SSA. When you have a pair and another side, right? Pair plus side is technically the definition of SSA. I just came up with that right now. Pair plus another side is SSA. Okay. All right, let's do this. It's what kind of angle is this? Acute, right? So this is the messier one, right? So we draw our triangle like this. We didn't catch the fish yet. Okay. So this is 75. The side across from it is 9.5. Okay. And then the other side is going to come in here. There. We're going to call this rod. We're going to call this string. Right? So we're going to compare the string and the rod. What do we notice? They're close, but the string is shorter, correct? So you go like that. So we have to find the height now. So I tell myself, find height. In this case, we do care about the height. How do we find the height again? It's this diagonal that touches the angle, right? So we're going to go 9.7 times sine of 75. That is 9.36, sorry, 37 if you round it. It's okay to round to 2 decimals. And we are in miles. So this is almost like an aside, folks. I need the height once, so I'm going to actually write it. I'm going to make this appear here for now. In my triangle, I'm going to introduce the height there. Okay, so the 9.37 goes right there. Now I ask myself, I will compare the string and the height now. What do I notice? That the string is slightly bigger than the height, correct? But it still makes this statement true. How many triangles will I have in this case? 2, right? 2. If you go to that little flow chart, string shorter than the rod, string is longer than the height. So therefore, 2 solutions, 2 triangles. Both are equally, they're saying the same thing. We're saying the same thing. Okay? All right. Let's pause here for a bit. So we still have 4 minutes. So go to 107. And every time it says textbook in my booklet, we do not have a textbook, right? So you just don't worry about it. I'm just going to say flat out page 107 to 110, I believe. And it seems like a lot, but it's not a whole lot that I'm not going to take you very long if you're just on it. And you might be like, I did this on the whiteboard, Mr. Dirksen, so why would I do it again? There's something different happening when you do it by yourself in this booklet one more time. And there's more of these. Like if you feel like 107, I got this, Mr. Dirksen. If you go to 110, I do that all over again. Okay, I do that same exercise again. I need you to be fluent with this, right? I need you to be good at it because you might think this was a lot to take in. This is just a little piece of, because once you start solving these ones, that's when it gets a little, it's just more work. That's not going to be new. It's just more work. But imagine if you have two triangles, what does that mean? You have to solve for two triangles, right? So that's going to get a little weird, but we're going to do it. So make sure you do this by tomorrow. I need you to be quite comfortable with it. Have something on your study sheet that helps you with this, okay? I think tomorrow, if I give you an AC, I will allow you to use your booklet just tomorrow to have this little flow chart, right? Because some of you might still need that flow chart. I'll give you a very short version of this tomorrow. There's something, I can honestly fit it in like a 2x2 box, right? So we'll do that. Thank you guys.